Hey everyone, it's Miss Burgess. I hope you had a good weekend. Today our topic is angles from chords, secants, and tangents. So we are solving problems using chords, secants, and tangents. Quick review. A chord is a line segment with endpoints on the circle. So it looks something like this. We have a circle and a line segment with endpoints on the circle. So this is a chord. Okay. A secant is a line with points on the circle. So don't forget what a line is. Okay, straight line that continues infinitely in both directions with points on the circle. So this is a secant. Okay, and then finally, tangent we learned last week. A tangent is a line that intersects a circle at exactly one point. So here's our circle. We'll call this the tangent point, and our line crosses the circle at only one point. Okay, so this is a tangent. Okay. So, we're going heavy on the notes this week. Sorry about that. And in place of IXL, I gave you some extra work to do in the notes, and hopefully that doesn't bother you. So, the first thing that we're going to learn is what happens when two secants or chords intersect. So let's go ahead and review what it says. It says when chords, secants, and tangents intersect in a circle, that's figure 1, on a circle, figure 2, or outside of a circle, figure 3, special relationships exist between the angle and arc measures formed. Okay, and none of this math is hard, right? It's just using logic. So the first one we're going to learn is figure 1. It says, if two secants or chords intersect inside a circle, then the measure of the angle formed is equal to half the sum of the measures of the intercepted arcs. So the measure of angle 1, and I'll outline angle 1, is equal to half of the sum of the measures of the intercepted arcs. So the intercepted arcs this time are AD and BC. So half of the sum of the measures of the intercepted arcs, half of measure of arc AD plus the measure of arc BC. Okay, and the measure of angle 2 is 1/2 of the sum of arcs. So here's angle 2, AB plus CD. Arc AB plus the measure of arc CD. Okay, so for these notes, I decided to do the harder ones. I'll leave you guys the easier ones. I'll do the right side. You guys can do the left. So I'm starting with number 2. So number 2 says, find the measure of angle STR. Here's STR. Our angle STR is equal to 1/2 of the sum of 112 plus 186. So we're going to do 112, 112 plus 186 multiplied by 1/2 or divided by 2. So angle STR is equal to 149. Degrees. Okay. So hopefully that one was pretty simple. Number 4. We'll do the measure of arc LK. So they don't give us LK. Obviously, we'll call that X. We're going to say that our intercepted angle is 62. So angle 62 is equal to 1/2 of X plus 74. Okay, so we need to get rid of the 1/2 to make this equation simpler. So we multiply by 2 on both sides. The 2 cancels the 1/2. 2 times 62 is 124 equals x plus 74. Subtract 74 on both sides, and you get x equals 124 minus 74 is 50. 50, okay. Okay, all right, let's do it again. Now we are finding our QT. So here's our QT, we'll call this x. They didn't give us our angle, so we're going to have to know that RT is a straight line. To find that angle, we're going to do 180 minus 79 is 101. So that's angle QUT is 101. Okay, so we'll set it up the same way as the problem above. We'll do 101 equals 1/2 of our sum of the intersected arcs. So that's x and 95. Okay, so we get rid of 1/2 by multiplying by 2 on both sides. That's 202 equals x plus 95. Subtract 95 on both sides. X is 107. X equals 107 degrees. All right, so this is just a math trick that you can use anytime you have two secants or two chords intersecting, and it will help you solve problems. All right, so let's go to the next thing. If a secant and a tangent intersect at the point of tangency, then the measure of each angle formed is equal to half the measure of its intercepted arc. Okay, so this one actually, guys, is even easier than the last one. So if we have angle 1, okay, is equal to half of the measure of its intercepted arc, and our intercepted arc for angle 1 is AB. So the measure of arc AB. That's it. Just multiplying by 1/2. Okay, so angle 2, here's our angle 2, is equal to 1/2 of its intercepted arc. And this is major arc BCA, or I'll just call it ACB. Okay, so let's do number 8. Number 8 says, find the measure of angle DCB. All right. Well, they didn't give us even its intercepted arc, so we're going to have to find it, right? We have a whole circle, which equals 360, and it's cut into 2 pieces. So let's do 360 minus 192. So its intercepted arc is 168. So angle, the measure of angle DBC is equal to 1/2 of 168, which is, I think it's 84, but let's just double check. 84. So angle DBC is 84 degrees. Okay. So for number 10, finding the arc, major arc KNM. So that's this one here. Okay. They don't give us our angle measure, of course, so we're going to do 180 because it's a straight line JKL. So 180 minus 23 gives us angle MKL, which is 157. 157. All right. So we'll call this X. This time they give us our angle. Well, we had to find it, but 157 equals 1/2 of X. That's our arc that we're looking for. So to solve this one, we just multiply by 2 on both sides. So 157 times 2 is 314. X equals 314, or arc, the measure of arc, KNM, is 314 degrees. All right. So the third thing that you guys are learning is, let me scroll up just a little. What happens if secants or tangents intersect on the exterior of a circle? Then the measure of the angle formed is equal to half of the difference of the intercepted arcs. Okay. So here we have angle A. This is our angle A. And its intercepted arcs are CE and BD. Right? So the measure of angle A is equal to 1/2 of the measure of arc CE minus the measure of arc BD. Okay. So if you're given a secant and a tangent, it's the same exact thing. I know it feels like you're learning 3 different things. It's truly the same. We have our angle A, and the intercepted arcs are BD and BC. So 1/2 of the difference of the intercepted arcs, arc BD, the measure of arc BD, and the measure of arc BC. Okay. And so if you're given 2 tangents, and I'm really sorry for my handwriting, guys. I feel like it's getting better, but maybe not. We have angle A. Oh, look, I picked the same color. Oops. Is equal to 1/2 the difference of the intercepted arcs. This time we have a major arc, BDC, minus the measure of BC. Okay. So I'll do number 12. You guys can do 11. We are finding angle BCD. So the measure of angle BCD, and that's this tiny angle right here, is going to be 1/2 of 67 minus whatever this is, right? So we got to figure out what that is. Okay. So we know that from B to A, arc BA or AB is 180. How do we know? It's intercepted by a diameter. So diameter AB goes through the center. So this is 180. Okay, so we can figure out just by adding 94, 67, and 180 and subtracting from 360 to find that little missing piece. So we're going to do 94 plus 67 plus 180 is 341. Okay. Subtracted from 360 is 19. So that little piece that we needed was 19. So the measure of angle BCD is going to be equal to 1/2 of 67 minus 19. All right, well, that's pretty easy. 67 minus 19 and divided by 2. That's 24, so the measure of angle BCD is 24 degrees. All right, so if you want to pause the video and work through the ones that I've skipped up to now, that might be a good idea because the next 4 problems are challenge problems. Okay. Again, I'll do 15 and 16 and leave 13 and 14 to you. The only thing that makes this harder is it's algebra. Number 15 looks like what we just did here with a tangent and a secant. So this one, right? That's this one here. Okay, let me erase that. Arc QT. QT is 27x plus 3. Okay, arc RT is 9x minus 5. And angle RST, oh, they gave us everything, that's nice. So angle RST is 10x minus 2. Okay, so we say the angle, 10x minus 2, is equal to half of the difference of the intercepted arcs. So I'm going to do 27x plus 3 minus the smaller intercepted arc, 9x minus 5. Be careful, guys, that you put this in parentheses so that you need to distribute this negative right here, right? So let's simplify before we solve. 10x minus 2 equals 1/2 of 27x plus 3 minus 9x plus 5. 10x minus 2 equals 1/2. 27 minus 9x is 18x. 13 plus 5 is 18. Okay, so we can either multiply by 2 to get rid of the 1/2, or we can actually take a half of 18x and 18, which is what I'm going to do. So that gives me 10x minus 2 equals 9x plus 9. Subtract 9x from both sides, that gives me x. Add 2 to both sides, that gives me 11. X is 11. I'm going to write it over here. Okay. So that was number 15. But did we solve the problem? No, because they asked for arc RT. So RT is the measure of arc RT is equal to 9x minus 5. 9 times 11 minus 5. 99 minus 5 is 94 degrees. What happened? Sorry. 94. I'm not going to... Oh, I can't write the degree symbol. There. Look, I did it. But now I can't go back. Okay. Sorry, computers. All right, number 16. So 16 says angle JKL is 8x minus 6 degrees. Right. So this angle is 8x minus 6. And major arc JML is 25x minus 13. Oh, this is interesting. Find that degree of the major arc. Okay, So they didn't give us the other intercepted arc, JL. So that stinks. It makes the math a little harder. Okay, but we can do it. So 8x minus 6, our angle, 8x minus 6, is equal to 1/2 of our major arc, 25x minus 13, minus, okay, well, we don't have any information here, but we do know that the whole circle is 360, correct? So we're going to say minus, and I'll just put it in brackets, 360 minus the major arc, 25x minus 13. Oh. Okay, had to get creative there, but I think you guys can follow. So we are going to simplify everything in that parentheses here. So 8x minus 6 stays the same, equals 1/2 times 25x minus 13 minus 360 minus 25x plus 13. That's a 360. Okay, again, simplify again. It's a lot of writing, but it's algebra. Write everything out because there's lots of room for error. So 360 plus 13 is 373 minus 25x. Okay, we're almost there. Bear with me. There's lots of lines. 25 minus, I lost my x throughout the whole problem, sorry. 25x minus 13 minus 373 plus 25x. Plus 25x. What am I doing? Okay, can I come over this way? Can you make it larger? Not that much. Okay. Sorry. I'm trying. Okay. So I think we're finally ready to simplify this. Let's go down just a little, computer. You can do it. Okay. 8x minus 6 equals 1/2 times 25x plus 25x. That's 50x. 13, negative 13 minus 373. Negative 13. Nope. Minus 373 is negative 386. I really hope this works out. Okay. This time, I think I'm going to multiply by 2 on both sides. So times 2, times 2. Right, these cancel. Okay, that gives me 16x minus 12 equals 50x minus 386. Okay, 50 minus 16. It's really late, my brain's not working. 50 minus 16 is 34. 34x. And negative 12 plus 386. So I will do negative 12 plus 386 is 374. Please work out. Divide by 34 on both sides. divided by 34. 11, yay! Okay, so we got x equals 11. That doesn't answer a question, right? Because they want arc JML. So that's our major arc. 25 times 11 minus 13, right? So major arc JML is going to be 25 times 11 minus 13. 262. And that actually does look right. So 262 degrees. Okay, so that one was pretty hard, but I feel like the rest was pretty easy. Go ahead and finish up these notes and send them to me. Don't forget your summary. And if you have any questions, let me know. I'm here. Okay, good luck. Bye.